Alright, so in this problem, I have 4 to the power of x is equal to 40. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 4 to the power of x is equal to log 40. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is equal to b times log a. So in this case, I have log 4 to the power of x, so I can move x to the front. So now I have x times log 4 is equal to log 40. Now, I'm going to go ahead and divide both sides by log 4. So then these two cancel out, and now I have x is equal to log of 40 over log 4. Now, log 40, this is the same thing as log of 4 times 10. Is log 40 is equal to 4 times 10. So I have this over log 4. And now if I have something in the form log a times b, this is equal to log a plus log b. So in this case, I have log 4 times 10. So this is equal to log 4 plus log 10. And now I have this over log 4. Now log 4 plus log 10 over log 4, this is the same thing as log 4 over log 4 plus log 10 over log 4. And log 4 and log 4, these two cancel out. So now I have x is equal to 1 plus log 10 over log 4. So now log 10, this is the same thing as 1. Log 10 is equal to 1. So now I have x is equal to 1 plus 1 over log 4. And log 4 is equal to 0.602. So now I have x is equal to 1 plus 1 over 0.602, which is equal to 1 plus 1.66, meaning x is equal to 2.66. Alright, so in this problem, I have x to the power of x to the power of 4 is equal to 64. So I need to find the value of x here. So for my solution, I'm going to first start by taking the power of 4 on both sides. So now I have x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can switch the places of m and n here. So in this case, we can think of x to the power of 4 here as m and 4 as n. So if I switch the places of these two, I get x to the power of 4 to the power of x to the power of 4 is equal to 64 to the power of 4. Now I'm going to replace 64 with 8 squared. So now I have x to the power of 4 to the power of x to the power of 4 is equal to 8 squared to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So a to the power of 2 to the power of 4, that's going to equal a to the power of 2 times 4, which is equal to a to the power of 8. So I have x to the power of 4 to the power of x to the power of 4 is equal to a to the power of 8. Now I'm going to let x to the power of 4 equal to the variable y. So now I have y to the power of y is equal to 8 to the power of 8. And if I have something from a to the power of a is equal to b to the power of b, this means that a is equal to b, meaning y is equal to 8. Now remember how we let x to the power of 4 equals y. So if x to the power of 4 equals y and y equals 8, then this means that x to the power of 4 is equal to 8. So now to solve this equation, I'm going to take the fourth root on both sides. So the fourth root of x to the power of 4 is x, and so I have x is equal to fourth root of 8. So now to check, my original equation was x to the power of x to the power of 4 is equal to 64. X is equal to the fourth root of 8, so now I have fourth root of 8 to the power of fourth root of 8 to the power of 4 is equal to 64. Now the fourth root of 8 to the power of 4 is simply 8, so now I have fourth root of 8 to the power of 8 is equal to 64. Now, this is the same thing as 8 to the power of 8 over 4 is equal to 64, meaning 8 to the power of 2 is equal to 64, and 64 equals 64. So this is right. Alright, so in this problem, I have x to the power of 4 is equal to 4. So I'm going to first start by subtracting 4 on both sides. So then these two cancel out, and now I have x to the power of 4 minus 4 is equal to 0. Now x to the power of 4 I can rewrite as x to the power of 2 times 2, and 4 I can rewrite as 2 squared. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, that's going to equal x to the power of 2 to the power of 2. Now I have this minus 2 squared is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 2. So I have x squared plus 2 times x squared minus 2 is equal to 0. So now this gives me two equations. I have x squared plus 2 is equal to 0, and x squared minus 2 is equal to 0. So for x squared plus 2 equals 0, I can subtract 2 on both sides, so then these two cancel out, and I have x squared is equal to negative 2. So now to solve this, I'm going to take the square root on both sides. Square root of x squared is x, and the square root of negative 2 is the square root of 2 times the square root of negative 1. Now, if you guys already know, the square root of negative 1 is equal to I. So I have x is equal to positive or negative square root of 2i. Now for x squared minus 2 equals 0, I can simply add 2 on both sides, and I get x squared is equal to positive 2. Now to solve this, I'm going to take the square root on both sides. Square root of x squared is x, and the square root of, and this is equal to positive or negative square root of 2. So now I'm going to check. My original equation was x to the power of 4 is equal to 4. So the square root of 2 to the power of 4, because this is an even exponent, it doesn't matter if it is positive or negative, it's going to be the same result. The square root of 2 is the same thing as 1/2, so I have 2 to the power of 1/2 to the power of 4, which is equal to 2 to the power of 2, which is equal to 4. So this works, and for the square root of 2i, it's exactly the same thing. There's no difference. So my 4 solutions are right.